night of sections 7 and 8. So are there any questions from section 7? Get that to all show up. Okay, so we've got Sydney investing $100 every month into an account that pays 5% annual interest, compounded monthly. And then Benny is investing $80 every month into an account that pays 8% compounded monthly. And basically we're going to be comparing those two. So we need our formulas, which our periodic deposit formula so this is when we're making periodic deposits, how much we're going to have at that future date. So for Sydney, we've got $100 a month, 5%, and we're compounding monthly, so n equals 12. For Benny, we have $80 a month at 8%, and will be 12. Okay. We want to know how much is in Sydney's account after 10 years, so this makes T equal to 10. Our principal is $100 a month. Our rate is 0.05 for our 5%, n is 12. We have 12 times 10 years. Okay. Dividing that number is 0.00416 repeating. Okay, and 12 times 10 is 120. So I'm going to add 1 to my division. I'm going to raise that to the power of 120. I'm going to subtract 1 from it, and then I'm going to multiply it by 100. And that gives me a new numerator and I'm dividing that by that 0.00416 repeating. So at the end of 10 years, excuse me, Sydney's going to have $15,528.23. Okay. For B, we want to do the same thing for Benny. But Benny's putting in $80 a month instead of 100, and 8% interest instead of 5. Okay, so 0.08 divided by 12 is 0.006 repeating. 12 times 10 is still 120. So add 1 to my decimal. Oops, I subtracted 1. Hold on. Helps if you hit the right buttons. So add 1, raise it to the power of 120, subtract 1 from it, and then multiply it by 80. And I get a numerator of 97,57,121,875. I'm dividing that by my 0.006 repeating. So at the end of 10 years, Benny is going to have $14,635.68. C is asking who has more money in their account. That's Sydney. Okay. This is after 10 years. And then D wants us to do 20 years. So I'm going to set up the account, or the formula. We're still with Sydney, so we've got $100 a month, 5% interest, 20 years. Excuse me. This number will be the same. This number is going to double. Instead of being 120, it's going to be 240. So I take my decimal, add 1 to it, raise it to 240 this time, subtract 1 from it, and then multiply it by 100. And my numerator this time is 171.2640285. Divide it by my decimal. $41,103.37. And then E is asking us about Benny's account after 20 years. So 8% divided by 12 and $80 instead of 100. 240 will still be our exponent. This is going to be 0.006 repeating. That didn't change. Add 1 to that. Raise it to the power of 240. Subtract 1 from it, and then multiply it by 80. And Benny has $47,121.63. So after 20 years, Benny will actually have no money, even though he deposited less every month. Anybody know why that is? Okay, the reason that Benny ends up with more money, even though he's depositing less per month, is because his interest rate is 3% higher. So he's actually earning greater returns on his money than Sydney is. Now in the short term, the higher deposit is going to get you further, but in the long term like that, the higher interest rate is going to get you further. So if you are planning out long term, you can actually deposit a little bit less and get better returns if you can find a higher interest rate. If you're talking short term, you want to have higher deposits to increase faster, and a lower interest rate at a higher deposit would actually get you further. Of course, ideally, you would do Sydney's deposit with Benny's interest rate, and that would earn you the most altogether. Okay, 75, we've got Sydney repaying a school loan, and she wants to repay it in 4 years. We want to know how much is she going to deposit semi-annually into an account that pays 3.9% interest, compounding semi-annually to have $100,000 to repay the loan. Okay, so this is present value of periodic deposit. Okay, so this is one of those, I have a goal, I need 100,000 Yeah, $100,000 in 4 years. So how much do I have to put away periodically to get there? And that is, periodic deposit is equal to the balance I want times the rate divided by compounding over 1 plus the rate divided by compounding to the NT minus 1. Okay, so that's this formula. My goal is 100,000. My rate is 3.9%, so 0.039. Compounding semi-annually, N is 2. So my annually is twice a year. Two times 4, because it's 4 years. Okay. If I divide 0.039 by 2, I get 0.0195. And 2 times 4 is 8. Multiply that times 100,000. Bless you. Bless you. Okay, multiplying this times 100,000, I get 1950. If I take 1.0195 and I raise it to the power of 8 and then subtract 1 from it, I get 0.167072514. So I divide 1950 by that. Oops, that didn't work. She's going to have to put $11,651.58 into the account every 6 months. And in 4 years, she'll have her $100,000 and can pay off that loan. Okay, 76 says Rich needs $50,000 for down payment on a home in 5 years. So he needs $50,000 in 5 years. How much must he deposit into an account that pays 6% interest quarterly? So that makes N is 4. Same formula as our last problem. Oops. So $50,000 is our goal. Our interest rate is 0.06 quarterly, so divided by 4. And our time is 5 years. Okay, so this is 20. 0.015 here and 0.015 there. That's 750. I take the 1.015, I raise it to the power of 20, and I subtract 1 from it. And then I divide 750 by that. So he needs to put his deposits $2,162.29 every 3 months. Because quarterly is every 3 months, because you divide 12 by 4, you get 3. All right, so on 17, we're going to balance this checkbook. And have to find the ending balance on the statement. That's right
So
here.
that's 4234 monthly,
Yeah.
right?
That's right there. That's the answer to A. Okay. The total of outstanding deposits. Well, in order to find that, we first have to figure out which deposits have cleared. So we go in here. The $600 deposit cleared, so we check that off. We just go ahead and check off all of these. The $79 withdrawal.
So they just wanted us to use a statement to reconcile the.
Yeah, we're reconciling it with this check register and this statement. 5110 cleared. $12 that cleared. 133.81 that cleared. $250 deposit cleared, and an 1140 cleared. Okay, so all the ones I just checked off are all the ones that are right here. So those cleared. So our outstanding transactions are these ones here that haven't cleared. Okay. So B is outstanding deposits. Well, those two both cleared, so it's just this one, so it's $700. We don't have to add anything. C is outstanding withdrawals. There's two of those.
So it's the 39 and the 50?
Yeah, 39 plus 50. Okay. D is revised statement balance. Okay, now to find the revised statement balance, we take our ending balance
Our ending balance
from the statement.
Okay.
Okay. Okay, the statement ending balance, you add outstanding deposits and you subtract outstanding withdrawals. That's how you get your revised statement balance. So in this instance, we're going to take our ending balance, which is 143,419. We're going to add 700, and we're going to subtract 89.
What I got matches what she has.
It should. Okay, this is the revised statement balance. Okay, that's D. E is what's the balance on the check register. That's this last balance right here, that's E. And then F, does the account reconcile?
Yeah.
If this matches this, yes. If not, there's a mistake somewhere, you gotta go hunt for it. But as long as these two numbers here match, you're good, you're golden. Alright, so our balance on 1215 is 24254650. So that's our balance forward. On 216, we write a check, 2345. Be sure you put your check numbers in. I will mark off if you don't. Kings Park, High Student Activities for $54. Okay, and we have to subtract that from this number here, which leaves us with 2492.50. So I subtracted $54. Okay, so that's those two. On 1217, deposit paycheck. I usually just put a D there for deposit. 324.20. That gets added. Okay, that's done. Your grandparents send you a holiday check for $100, which you deposit on 12/20. So I just put that there. It's $100. Okay, that gets added in. 1222, you write 3 checks. Okay. 2346 is to Best Buy. For $326.89. 2347 is to Macy's for $231.88. And 2348 is to Target for $123.51. Now I have to subtract out each of those separately. Okay. On 12/24, I go to the Apple store and I'm writing a check, and I make a mistake, and so I void it. Okay. You have to record the voided check. That's $23.49. The reason you do that is because, remember I told you guys check numbers can only be used once. If a check comes through your account that's numbered $23.49, that means somebody probably stole your information, and that's probably a fraud, and you want to be able to flag it. So the next check is $23.50. You put the Apple store, and it was $301.67. This next line right here, some people like to carry the balance down, some people just leave it blank. That's personal preference. As long as you subtract for this line here, that's fine. So if you rewrite this same number twice, that's cool. If you don't, that's cool too. Okay, 12/26, you return a holiday gift, which you deposit into your checking account. Okay. Ah, I didn't give you enough lines. Sorry.
Yeah, we're too short.
One short. The fees go right here in the other column. So on 12/28, we're going to go to Allstate, generate our insurance check for $876. Okay, and then 12/29. That's what happened. This is I didn't press enter, and that's why I didn't give you an extra line. You withdraw 200. Okay, that's an e-check, so I would do like EFT. And 12/29 is withdrawal of $200. The fees go in this other column, so $1.50 goes right there.
How about if you just added in with the 50 or the?
If you put 201.50. Yeah, that's okay. But if you do that, do withdrawal plus fee right there, so that you know that that's where that extra $1.50 came from when you're trying to reconcile later. Because when you reconcile later, the fees will show up as a separate thing, and it won't be listed in this column. It'll be over here, so you want to be able to account for it. So you could just put like a W there for withdrawal. We're going to add this $98 in. So you get 20, 30, 75. Subtract that 876. 1154.75. Subtract 201.5. You have to subtract both of those. 953.25. So this is simple interest, okay? So this is IPRT. So if you have P and R and T, you solve for I. So you plug in P and R and T. If you have I and P and R, you're solving for T. So we're just looking for the missing blanks here. So it's always simple interest, I equals PRT. We don't have I, but we have principal, rate, and time. So do 2,000 times 0.0335 times 4. So that's A, 268. Like that. B, same idea. Principal's 3,500. Rate is 0.041. Time is 15 months, so you have to do 15 divided by 12.
Okay, so it wants us to get, with this information, it wants to know how much interest we would get.
On when you've got the first column missing.
Okay.
On this next one down, D, you have the time missing, so I'm going to skip to D. And you have 100 is equal to 700 times 0.088. You don't know time. So you're going to solve for T on that one. So you'd get 100 is equal to 61.6 T. You divide both sides by 61.6. So T would be 1.6 years. And then like for F, you don't have R. You have P and T, so you'd solve for R. And then on G, you have R and T, but you don't have P. So basically this table is your formula. Does that make sense now? Okay. Any other questions on that problem? That was number 26.
Can we do that for 30 on the same page?
Yeah. Same idea. We've got we have principal, that's the 9,500. We've got interest, that's the 900. We've got time, 19 months, so that's 19 divided by 12. What we don't have is R. So I'm doing 9,500 times 19. Then I'm going to divide it by 12. Okay, and then I'm going to divide 900 by that answer. Move it over 2 places. It said to the nearest hundredth. That was a 3 after there. So it's going to be 5.98%. Oh, you guys can't even see any of that, could you? Sorry. Anthony, did you ask for continuous compounding? Okay. 68 is one?
So you need 5.98% interest?
Yeah, in order to get that amount of interest, you would have to have 5.98%. Okay, so 58, we've got $50,000 deposited, 6 years, 4 1/8% continuously. Wrote it down. That's our formula. Okay, so your principal is the 50,000 that you deposit. E is a calculator button, or you can round it 2.718. Our rate is 0.04. Okay, So I'm going to do 1 divided by 8, and that's 0.125, and t is 6. Okay, so if you're doing the button in the calculator, can you guys see that at all? Is that better? Okay. So if I'm doing the button in the calculator, I put in the second function. See that e to the x right there? That's an e with an x over it. So I'm going to use that button. Okay, and then I put in 0.04125 times 6. And that gives me the e to the exponent part, and then I multiply that by 50,000. Okay. This actually, using the calculator button, is going to be the more accurate. E is about 2.718. So if you don't have the calculator button, you do 2.718 raised to the exponent of 0.04125 times 6. If you look, 12808 versus 12807, it's just slightly off. Oops. Then you multiply that by 50,000. Okay. 4039. My answer key will say this. But I know that if you use 2.718 for you, because you're not using the calculator button, I know it's going to be this far off. I would not mark this wrong. This is close enough. Now, if you had like 62,000 something, then there's, but if you're within like $1, you're fine because of the rounding. And I know that rounding makes a difference in these because of the exponents and the decimals that you're getting. So if you're in the ballpark, you're good. If you're playing the other sport, like if you're not in the ballpark and you're on the tennis court, that's not okay. Um, 59?
It's just a percentage. If one of the banks pays 4.1 and the other bank pays
4.01? Yeah. Sure thing. Okay, so you've got, well, one's compounding monthly and one's compounding continuously also.
Right.
Did I write that down right? Second guessing myself on the formula. It is, okay. So this one is 4.1% monthly, and this is 4.01% continuous. Okay. So same 9,000. And 2 years. So that number is 0.0802. That's 24, and this is 0.003416 repeating. So I'm going to take that, add it to 1, raise it to the power of 24, and then multiply it by 9,000. Okay. That is State Bank. This is going to be King's Bank, so I'm going to use the E button, raise it to the power of 0.0802. Oops. Multiply it by 9,000. Okay, so the interest on this one is $767.74, and the interest on this one is $751.53. State is higher. By $16.21. Okay. Now that's because of the difference in the decimal place. This is 1/10. This is 1/100th. So that's what made that difference. If the interest rates were the same, the continuous compounding would have paid higher. Okay, now this is just for 2 years. Over the long run, should probably earn more interest continuous compounding. Not a lot more. There's not a huge amount of difference between these two, but over the long run, this one is going to pay slightly more interest. But by long run, I mean 20, 30 years. So when they ask what other factors might affect her choice besides interest, the length of time she's planning to leave that money in there would affect her choice. Also, you know, what other things do the banks offer? What is their fee structure? What perks do they have? You know, those are the things you also want to look into. You don't want to just look into interest, but you want to look into the other aspects of the bank. Their fees, like, you know, overdraft protection, loyalty rewards. Some banks, if you have the same account and you keep it in good standing, will raise your interest rate after so many years, as long as you're keeping above a certain balance. You know, there's all kinds of programs like that, so you want to look into, that's the kind of stuff you would look into aside from just the interest. Okay. All right, so that's the continuous compounding, and we've done some regular old compounding, and we've done some simple interest. We've also done a check register, and we've balanced an account. You guys remember I told you that one of these would be on the test for sure?
Yes, if you're just going to do number 40.
Absolutely. Okay. You mean 41?
No, we're not in 41.
Did we do 41? How about 42?
I'm sorry, yes, 41.
Okay.
You're correct.
It's cut off. I punched it out with the
That's
hole.
what I meant.
Yeah.
41.
Okay, so Jacob opens an account in a non-leap year. So non-leap year means 365 days. On August 10th with a deposit of $4,550. Okay, that's his deposit. The account pays 0.04 interest, and it's compounding daily. Okay, this is August 10th. He had no money because he opened the account. He did not withdraw any money. The principal used to compute interest is the same. And so we need to figure out his interest for the day. Okay. His principal is 4550. His rate is 0.04. N is 365. His time is 1 day. So 1 over 365. Can you guys read that? Is that better? So 0.04 divided by 365. Okay, these two are going to cancel each other out, right? Those 365s? So that's the same as that. So this is just going to equal 1. So I do 0.04 divided by 365, and then I add 1 to that. If I raise it to the power of 1, nothing changes. Hold on a minute. What did I do? Use simple interest formula for these. Okay, our rate, our time is 1 over 365. That's what I did. So I multiply by 0.04 and then I divide it by 365. So 50 cents. So my day's ending balance is there, which makes my day's opening balance the same for the next day. Okay. August 11th, he deposits $300. August 12th, he withdraws $900. And we need to fill in all the other missing amounts. Okay, so I add those together because that's deposit. I calculate the interest on that. So 4850.5 times 0.04 divided by 365 gets him 53 cents. Okay, that's this balance up here. He takes out $900. That's what I use to calculate this next interest. So 395103 times 0.04 divided by 365. 43 cents. I don't know why I did that. That would be end of day, August 12th. If we compound weekly, it's compounding 52 times a year. If we compound daily, it's compounding 365 times that year. We've got 5 years. Same formula for both of these. The only thing that will change will be the N. So we have 5,000 at 0.047. Here's the weekly. And then we did 5 years. Or daily. Okay, so 52 times 5 is 260. 0.047 divided by 52 gives me this big old long decimal. 0.00090 whatever. So I add 1 to that. I raise it to the power of 260. And then I multiply it by 5,000. So that's what weekly compounding gets me. Okay, daily compounding, 365 times 5 is 1825. So I do 0.047 divided by 365, which gives me a long decimal. Add 1 to that. Oh, that's 5,000, not 500. Take it to the power of 1825. and then multiply it by 5,000. Okay, and to actually figure out what's the difference, you actually do the subtraction. $0.58 difference between weekly versus daily compounding. Divided by 5 years, that's a difference of 11.6 cents per year.